Hi guys, over the last few weeks we've been looking at part-whole problems. This week we're moving on to something slightly different. Here we're learning to analyse and solve division problems. Now in each of these problems we're going to know the whole amount, but what we won't know is either the value of each part or how many parts there are. And we're going to use either shading or grouping in order to solve these. To begin with, let's get thinking. Here we've got a true or false, we've got a statement, and I want you to discuss with your partner whether you think this statement is true or false. And remember, I want you to justify, so give a reason why you think it's true or false. Harry has shared his chocolate frogs with his friends. So, pause the video for 1 to 2 minutes, discuss your thoughts, and share those with the rest of the class. I wonder if all of you in the class agreed here whether it was true or false. For those of you that said false, if you said it's false, he's not shared his chocolate frogs with his friends because they've not got the same amount each, then you could argue that you're right. If you said it's true, he has shared his chocolate frogs with his friends, and you justified that by giving a reason that, well, he's given each of them some chocolate frogs, then I would say that you were right also. Now in this situation, it doesn't actually say that they need to have equal shares. It just says he has shared his chocolate frogs with his friends. So in this situation, I would say it's true. He has shared the chocolate frogs with his friends. However, he's not made equal shares. And that's what we're going to be looking at today. So what could we do in this situation to make it not just that he shared the sweets, but he's given out fair shares? They've got an equal amount. Well, Harry could give one of his chocolate frogs to Hermione, and then they've got 4 chocolate frogs each. That way, he's not just shared with his friends, he's shared fairly. They've all got the same amount. Okay, here's another activity to get you thinking. What I want you to do this time is have a look at the following 2 problems, and in each case, I'm not necessarily interested in the answer, but I'm more interested in how you go about solving it. So what I'd like you to do is use resources, draw pictures, you might even want to use yourselves as a class, but I want you to have a go at working out how you solve the following problem. 12 children turn up for Quidditch practice. Madam Hooch wants to make 4 teams. How many children should there be in each team? Okay, so for this problem, we know that there needs to be 4 teams. So let's put out our 4 teams to start with. And then I want to know how many there should be in each team. So I'm going to start by putting 1 player at a time in each of those teams, until all the players are in a team and I know that I've shared out those players fairly. And I can see there that there are 3 players in each of those teams, and I worked that out by sharing. I shared the players between each of the teams equally. Let's have a look at the next problem. Here we've got the same 12 children turn up for Quidditch practice once again, only this time Madam Hooch wants to make teams of 4. So slightly different to last time where we had 4 teams, here she wants teams of 4. And this time we want to know how many teams should there be. So once again, pause the video for a couple of minutes, use resources, draw pictures, or act it out as a class in order to solve this. Okay, so this time it's slightly different. Last time I knew the number of teams, so I was able to put them out from the start, but this time I don't know how many teams. That's what I'm trying to work out. All I know is that I'm going to have 4 players in each team. So what we can do is we can start by taking those first 4 players and having our first team. After that, have we got enough for more teams? Yep, we've still got 8 players left. So let's take the next 4. And there's my second team. Let's take the next 4. And there's my third team. So in this case, we've got 3 teams. So the answer to each question was 3. However, the strategy that we used to solve them was quite different. In the first instance, we needed to share those players because we knew how many teams. In the second instance, we needed to group those players because we didn't know how many teams. What determined whether we shared or we grouped? The context of the problem determined that. So it's really important that when we're looking at division problems, they're set in a context, because that's going to help us determine the strategy that we're going to use. It's time to get investigating with a partner. Here I've got 3 problems that I want you to have a go at. The first one is 13 cookies have to be shared equally between the 4 children. How many cookies should they each get? The second one is 13 pens have to be shared equally between the 4 children. How many pens should they each get? And the third one is 13 people need a taxi to the airport. A taxi holds 4 passengers. How many taxis should they order? Once again, the answer is not the most important thing here. What's more important is that you're able to identify how you're working out each of these problems and you're able to explain. You can do that using the resources by drawing pictures. You might want to use bar models to help you analyse each of these problems first. Pause the video for 8 to 10 minutes and with your partner, have a go at analysing and solving each of these problems. Hopefully you've had a go at each of those problems, you've been able to analyse them, you've been able to solve them. Let's discuss them each in turn. So the first question, 13 cookies have to be shared equally between 4 children. How many cookies should they each get? So to begin with, I'm going to start by drawing my bar. And that represents the whole amount. So there we've got the 13 cookies, and I know that they've to be shared equally between the 4 children, so let's start sharing them out. As you can see, we've got 1 cookie left over. And what could we do with that 1 cookie? Well, we can't give it to any of the children because that wouldn't be fair. They wouldn't have equal shares. So we could put that back in the packet. If we did that, that would be fair. And the answer to this problem would be they get 3 cookies each. So if you've said 3 cookies each with a spare cookie left over, then I would say you're correct. However, some of you may have got a different answer because that cookie can be cut into 4 equal parts. And when we cut that into 4 equal parts, we get quarters. And once we've done that, we can share those quarters out. So all 13 cookies have been shared out. They've all got exactly the same amount. They've all got 3 whole cookies and 1 quarter cookie. Okay, let's have a look at the second problem. And in the second problem, we've got the same 4 children. And this time, it's not cookies that have to be shared out, it's pens. So we've got 13 pens to be shared equally between the 4 children. How many pens should they each get? Now, initially you might think, well, this is just the same question, only instead of cookies, we've got pens. So therefore, the answer must be the same. But let's think about this problem. Let's analyse it. So here, we've got our whole amount. I've drawn the bar to represent that. I'm splitting it into 4 parts again because they're to be shared equally between the 4 children. So let's start sharing those out just like we did with the cookies. And once again, we're able to give 3 pens each and we're left with this extra pen. Now, when it was cookies, we were able to cut that cookie into quarters and share that out. However, we're talking about a pen here. So this time, we can't cut a pen up. We would just break that pen. So that pen is a spare. We can do something with it. We can put it back in the box. We can give it to the teacher. We can give it to anyone else. But what we can't do is give that to one of the 4 children because then we wouldn't have equal amounts. So therefore, the answer to this problem is that they would get 3 pens each and there's 1 spare. Let's have a look at the last problem that I asked you to look at. Here we've got 13 people who need to get a taxi to the airport. A taxi holds 4 passengers. How many taxis should they order? When we analyse this problem to begin with, I don't know how many taxis we need. Therefore, I don't know how many parts to split this bar into. So this time, we're going to have a think about how we would solve this. And if we had 13 people waiting for a taxi, then the first thing we need is the first taxi to come along. And when the first taxi comes along, 4 people can get into that and off they go. We've still got 9 people waiting, so let's order another taxi. And the next 4 people can get into that and off they go. We've still got 5 people remaining, so we need to order another taxi for them. And 4 can get into that. And then we've got 1 person left over. Now we can't just leave that person behind, so that person would need a 4th taxi. So here we've got 13 people would need 4 taxis in order to get to the airport. Each of those problems, when we look at them, we're really asking us to divide 13 by 4. The first one, we had 13 cookies shared between 4 people. The second one, we had 13 pens shared between those same 4 people. And the last one was asking us how many lots of 4 can we get from 13? How many taxis do we need for those 13 people? We get 3 different answers to those problems. We get an answer of 3 1/4 cookies, 3 pens, and 4 taxis. Now each of those answers are correct. And each time we used a strategy. And how did we determine what strategy to use? The context of the problem led us towards the strategy that was most effective for that particular problem. So when it comes to solving division problems, the strategy that we use, and quite often the answer we come up with, are determined by the context. So context is really important when it comes to making decisions about how to solve division problems. It's time to have a think about our success criteria. So what I'd like you to do is pause the video for a couple of minutes and have a think about how did we achieve success? What were the steps that we went through in order to solve each of those problems? Hopefully you've had a think about your success criteria, you've come up with the steps that you go through. Here's what I think we needed to do to solve those problems. The first thing we needed to do each time was we needed to choose a strategy, whether to share or whether to group. And in each case, it was the context of the problem that helped us make that decision. Whether we shared out those cookies between the 4 children or whether we grouped those 4 passengers at a time into a taxi. Let's look at sharing to begin with. And when we solve a problem using sharing, the first thing we can do is draw the bar. And that bar represents the whole amount. Once we've drawn the bar, we can decide how many parts. Now in the case of the cookies, we were sharing them between 4 children, so we're going to split that bar into 4 parts. Once we decided how many parts, the next thing we had to do was share out fairly. And in this case, we shared out 3 cookies each. We then had 1 left and we decided that that cookie could be cut into quarters, which could then be shared out evenly. The last thing we need to do then is count the shares, and we can see there that each of the children received 3 1/4 cookies. Let's look at grouping now. We'll look at the taxi example. Here we had 13 people who needed to get a taxi. Now, in this case, we couldn't start by drawing the whole amount because we didn't know how many taxis we needed. So here, the first thing we did was we drew a part. And in this case, that part represented 1 taxi. The next thing we did was we took 4 of those people and put them in that taxi. So we took 4 away from the 13. Once we did that, we were then able to repeat until we had no passengers left. And all that's left to do is count up the number of groups or the number of parts. And in this context, that was taxis. And you can see there, we've got 4 taxis were required. It's time for you to try that out. Can you use the success criteria that we've just looked at in order to solve each of the following problems? The first question, we've got apples that are to be shared between the 4 children, and again here we've got 3 different sets of numbers. We've got red numbers for extra hot, green numbers that are spicy, and we've got yellow numbers that are our mild challenges. So choose one set of numbers. If I'm going for the mild problem, I'm going to read that as 10 apples are to be shared between the 4 children. How many apples will they each get? Second question, again, we've got red, green and yellow numbers, so this time I'm going to go for a spicy problem. 27 players turn up for Quidditch training. Madam Hooch wants to make 3 equal teams. How many players will there be in each team? And the last question, a carriage on the Hogwarts Express holds 6 passengers. How many carriages are needed for 75 passengers? So on that occasion, I've gone for the extra hot question. As before, when you're deciding on a set of numbers, look for the numbers that you think are going to challenge you. Don't go for the numbers that are too easy, don't go for the numbers that are too difficult, and once you've had a go at them, you can make up 3 problems for someone else to analyse and solve at your group. Next, it's time to reflect on the following with a partner. So once again, pause the video for a couple of minutes and have a think about the following questions. What have you learned today? What did you find easy or difficult? Did you get stuck? What helped you when something got tricky? What do you need more help with? What is really making you think? And what are your next steps? The last thing I'm going to ask you to do today is apply what we've learned. Can you use the success criteria that we developed earlier in order to analyse and solve the following problem together? The shopkeeper in Honeydukes has 27 chocolate frogs. A bag holds 6 chocolate frogs. How many bags does he need for all the chocolate frogs? And once you've done that, if Honeydukes sells chocolate frogs in bags of 6, how many bags can they sell? Thanks for taking part today. Hopefully you learned something. Hopefully you found that useful. You can contact me at scott.morrow@southayrshire.gov.uk, or you can tweet me at scottmorrowsa if you've got any questions or you'd like to share your solutions for today. Next week we're going to be analysing and solving multiplication problems, so I hope you join me then.